Hi everyone, my name is Martin Lehtoma and I'm a fourth year Information and Communications Technology student. I will be presenting my thesis topic which addresses the use of Java for image classification tasks. So let's get to it. So as I mentioned earlier, my name is Martin and the topic today will be image classification using deep learning with Java. The main objectives of this thesis was to demonstrate the use of Java for deep learning tasks such as image classification. By doing this, I'm leveraging a framework called Deep Learning for J, open source framework, and in general, the thesis is a practical point of view. The theory will not address any of the mathematical aspects of deep learning and machine learning. Yes, and why the topic? I came up with this topic because AI is a hot topic these days, and many businesses of diverse fields are leveraging techniques to solve their business problems. These are heavily implemented with languages like Python and R due to their low learning curve and simplicity as programming languages. Um, Java is not really recommended as a first option for deep learning because it's verbose and complex, but these problems are solved with a open source framework available called Deep Learning. It consists of high-level libraries and APIs that are well documented in their official websites, and they also have diverse examples available for different use cases. Deep Learning for J also supports Keras models, so this means that one can import a Python-based or Python-created Keras model into a Java-based project and leverage it there. So general cons of Java, it brings to the application security, performance, and scalability. And in addition, it's also cross-platform. This implies that compiled Java code can be executed on any platform which has the Java virtual machine support. Java has also a huge developer community, and that's also one of the main reasons it has a bunch of open source tools available. Often also tutorials related to deep learning, model creation, and so on only address the creation and evaluation of this model, but not really how to practically use it and deploy it. So this thesis also demonstrates through the whole machine learning pipeline, which includes problem definition, data gathering, preparation, to creating the model, and then deploying it successfully and using it. So how I started the implementation of this thesis, I start by introducing the main concepts of artificial intelligence, machine learning and deep learning, topics like artificial neural networks and deep neural networks, then followed up by image classification and how convolutional neural networks are leveraged most in that area. In addition to this, so one doesn't have to start from scratch by training the model. I demonstrated the use of pre-trained VGG16 models and the technique called transfer learning. And as the dataset we're working on is limited, also a technique called data augmentation is applied. In addition to these machine learning theories, I ended with introducing Java and its frameworks that can be leveraged for the creation of this project, and or not project, but rather the demonstration of how to implement these deep learning techniques. So open source frameworks used are Deep Learning for J, Spring Boot, Maven, and PyCocli. So the demonstration part consists of implementing a Java-based solution for image classification. The solution consists of two different applications. One is a command line tool, which handles the creation, training, evaluation, and saving of a compressed deep learning model. And then the other part of this solution is a RESTful web service where the trained model can then be deployed and used through frameworks. Used in these two applications are Deep Learning 4J, PyCocli, Spring Framework, or Spring Boot. Now, more in depth about the creation process of the model. So, as I said, it's a VGG16 based model. So, I have created a new model based on some features the VGG16 model has learned by performing transfer learning. The new model will be capable of classifying 8 different objects, such as gasoline cans, hammers, pebbles, rope, screwdrivers, toolboxes, wrench, and pillars. The dataset it's trained on is available in Google, and it consists of approximately 6,800 images. It is then split into 80% training data and 20% test data. And as said, the new model has a custom output layer with 8 output labels mentioned earlier. The data augmentation techniques include such as rotation, flipping, and wrapping of images. This enables the boosting of the training data. And then, of course, after the creation of the model, the rest of the walkthrough is about deploying and using the model through the RESTful web service. Our main achievements was the creation of a totally Java-based solution to tackle an image classification task with deep learning techniques. And as I said, there was the created command line tool and a RESTful web service. And the command line tool was able to train and create the model in approximately 30 minutes of training, and it reached 85% of accuracy, which is quite good in such a little amount of training time. The model was then successfully deployed and used through the web service. I will, after this, show a use example. All the source code for these two applications are available in my GitHub page. Now here's a use example of detecting a nail dispensing hammer as a hammer by using HTTP GET request to the web service. It then returns in response a JSON formatted response body with the classification is classified as. So here we can see that is indeed classified as a hammer, and the probability is like it's 77%. The probability is showed as decimals here. It also shows other predictions of rest of the labels. As seen, these decimal numbers can be confusing as they have the exponential mark in the end if it's a very small decimal. So, as I said, successfully Java-based solution with quite straightforward implementation. Now, what could have been done better was the theory section, which could have been planned better, and then it could have been connected more with the main demonstration part. And actually, an example of the creation of a model totally from scratch would have also been good, as we are addressing the use of deep learning 4J framework. Further development would include the creation of a generative adversarial network, which would boost training on a limited data set. So this is a model that would create new data or generate new data from the existing data. Also, some layer modification would have been good to do on the model's neural network, such as adding an additional dense layer and changing some of the feature extraction layers. Um, and then following up with unfreezing different layers during training. Now this unfreezing of different layers would enable some of the later layers of the model to be tweaked according to the specific dataset that we are used to tackle the image classification task. Now, growth of engineering is quite well reflected on this thesis because most of the open source projects are enabling developers to create these solutions. Without these frameworks, the use of Java, for example, would not be quite straightforward or recommendable. And other open source frameworks which drive the AI field are TensorFlow, Keras, PyTorch, and there are many more. In addition to these, making pre-trained models available for everyone really helps businesses to uh, leverage techniques in machine learning. Uh, the ability to use these techniques without having to start from scratch is it helps really to concentrate on the business logic. Yes, so that was all I have. If thanks for listening, and if there's any questions, you can uh, put them through comments or Optima. Thank you.